Hello, students of the statistical class at Mary Baldwin College. Psych 250? This is Dr. Tausman coming to you live from my house in Roanoke. After I've decided not to give you an exam on week 4, I'll give you some assignments at the end of the semester that I think will make sure that you understand the things that we tried to build the first 3 weeks. But I just wanted to kind of move on at this point because the z-test and the other stuff that we did, you're never really going to need to be able to do those specifically. Those are all building blocks to what we're going to get in this particular unit. So this unit will be important. The others were important as well, but simply as building blocks. We're going to follow the outline. Don't be too worried about the long nature of the outline. You're going to have to do a few problems here, but they're big tables and you just fill in the blanks. So even though it looks like a lot, hopefully, I actually find this stuff a bit easier to digest. And if you're able to follow week 3, you're doing a good job because I covered a lot of stuff pretty quickly there. And I tried to make it as specific and as directive as possible. So I'm hoping you were able to comprehend that. Starting today, week 4, we have a case study. Let's say I have a new drug, right? Because God knows that in our day and age, new drugs are the ways to help people. I have a new drug that I think reduces pain. I give this drug to 3 people and ask them to rate their pain simply 1 hour later. So they get a drug and rate their pain 1 hour later. It's a 10-point scale. One assumes that the higher the number, the more pain they have. So a 10 would be a high amount of pain. A 1 would be low. I do the same thing for 3 other people, but give them a sugar pill instead. It's a double-blind experiment, which means neither they nor the researchers know or the participants know what they're getting. And I collect the data there. So I put in the outline here, what are the variables here? So do I have any independent or dependent variables? And the answer, hopefully, that you would be able to figure out here is that I do have some variables here. The dependent variable, which is the variable that I measure, would be, do you know what it is? The pain rating. So pain rating would be the dependent variable. That's what I score on. That's a 1 to 10 score. So the DV is that. And in this case, how many independent variables would you say I might have here? Well, a lot of people actually many times say 2, but that answer would be wrong. If you say 2 independent variables, then you have to have more than 1 level of each. And so that can't really be, because if you say 1 independent variable is the drug and the other is the no drug, then what are the levels of that? Instead, this is a specific situation where you have 1 independent variable. You might call it product or group or condition. And then you have 2 levels, no medication and medication, or drug and no drug. So in this case, we have 1 independent variable, and you might call that condition or group, and 2 levels, no drug and drug. So in this particular case, you have 1 independent variable, 2 levels, and 1 dependent variable. So this is a very unique situation that we haven't seen yet, and we would need to be able to do a statistic on this. Notice as well with this specific case that everybody's only being asked to rate their pain 1 time. So the statistic that we might be asked to use, well, the question is, what have we learned up till this point? We've learned up to a z-test this point, but we're not going to be able to use that in this particular situation. The test we are going to be able to use is at the beginning of chapter 10 of each of your books, versions 8 and 9, and it's called the t-test. If you look at the start of chapter 10, it says the t-test for 2 independent samples. This is called the t-test for independent measures design if you open up to the first page, and this is a perfect case of that. We have 1 independent variable, we have 2 levels, and if you look at figure 10.2 in both books, you can actually see the example here in that figure. It's a different specific method and situation they're talking about, but we're interested in knowing if this drug works. We have 2 separate samples, what we might call sample A and sample B. Now, we have the samples, but of course, if you remember, what we really care about are the populations they represent. So we simply take those samples, we hope they represent their populations well, we have a good sample size, and we really want to see if population A and B are different here, those getting the drug versus those that are not. And so a t-test is the test you use. The other, and I want you to write obviously your notes on this, is the question would be, why can't we use the z-test here? Why can't we use the z-test? Well, I put the z-test formula there, and there's some very specific reasons why you can't use the z-test. If you look at that formula there, notice in the z-test you have to know two specific things about the population. When you do a z-test, you have to know mu, the population mean, like in the blueberry situation. I think we said mu was 80. You have to know the mean of the population. You also have to know the standard deviation of the population. In most situations, we never know anything about the population. If you know nothing about the population, which is the case for most psychology experiments, you cannot use the z-test. And that means that if you have this situation with a drug and a no drug, and a sample that gets each one of these, we know nothing about the population. So when you know nothing about the population, when you have two groups, you use a t-test. And in this particular situation, we're measuring one group one time, and we measure a second group one time as well. So if you measure two groups only one time, that is going to be the example of the independent sample t-test. I would hope that you can write some of this down. The beginning of chapter 10 in both of your books kind of covers this basic idea, but this is an independent sample design, and this is something that a lot of people doing research in psychology actually do, because this situation is real. Now let me move on to B here. A formula. You notice you had that Z formula before. Do you remember what we generally called the numerator and denominator for that Z-score formula? Do you remember what we called it? The numerator, we called it the treatment effect. Remember, you wanted a large treatment effect. You wanted the mean for a group that got the blueberries to be very different than the population as a whole. You want a large treatment effect. And then that denominator, you remember what we called the denominator? The standard error of the mean. We wanted that number to be low, anything with error in. How could you make sure it's low? Either a small standard deviation or a large sample size. So if you remember, that was the case for the z-score. If you look, I'm not sure if it's in your textbook here. Let's see if they actually have the t-test formula here in your textbook. It's kind of on the next few pages of your textbook, versions 8 and 9. But I actually put it in the text for you on the outline. It says if we assume that the two samples are drawn from distributions that are normal, take a look at that formula. It says T equals, and then it's got the numerator. The numerator is x bar 1 minus x bar 2. So I'm hoping that isn't anything too difficult for you. X bar 1, what is x bar 1? It's the mean of the first group. What is x bar 2? The mean of the second group. Notice how that formula is a little different, just a little different than the z-score formula. Remember in the z-score, it was x bar minus mu. Well, now we don't know anything about the population. So if we want to figure out something about the population, we have to use the two sample means. You could actually probably very easily figure out what x bar 1 minus x bar 2 is in the situation I gave you. Can you figure out what that is? The mean of one group is a 6. The mean of the other group is a 2. You take the difference, and what is the treatment effect? It's a 4. You want that number to be as high as possible, right? You want those getting the drug being very different than those that don't. So it doesn't matter which number you take first, positive or negative. I like to get a positive number. So the numerator there is called the treatment effect, and that's just the two means subtracted from each other. 5, 6, 7, the mean is 6. 1, 2, 3, the mean is 2. 6 minus 2 is 4, and the treatment effect, the numerator for that t-test, is a 4. Now take a look at the division sign in that denominator. Holy Toledo, SP square root 1 divided by n1 plus 1 divided by n2, 3, SP equals this, that, and the other thing. Holy Toledo. That denominator is a mess. That denominator, if you look in your book, and if you remember back to the z-score formula, is considered the standard error of the mean. And the good news that we have for you, if you are interested, we're going to actually have our computer program actually always get our standard error of the mean, so we don't have to compute it, because this is a big pain in the patella. So I put down in C, the numerator is the difference in the mean, also called the treatment effect, and the denominator is basically called the standard error of the mean. You will never have to compute that nasty little formula. We have plenty of computer programs that will do that for us. The simple idea here is that we want that number to be what? Small. We want a small standard error of the mean. That means our sample mean is close to the true population mean, and that's a good thing. So we're not going to ever have to compute that denominator. So hopefully that makes sense for you. Let's see, do I want to continue on with this? I think I'm going to stop the recording now and continue on in a minute.